This question, we are given a triangle. Can get from here a triangle, and it says that this side is 4 centimeters, this side is 5 centimeters, and this is the angle of theta in between, and let's call this side is x. Given that the area is 5 root 15 over 2, show that sine theta is equal root 15 over 4. Okay, the formula that we'll be using, the area is equal half A times B times sine theta, meaning any triangle, if you are given two sides, that's side A, that's side B, and the angle in between, then the area is equal half times the length of side A times the length of side B times sine the angle in between. That's it. Let's apply the rule in here. That'll be half times 4 times 5 times sine theta, and on the left hand side the area is given to be 5 root 15 over 2 equals 20 sine theta over 2. I can simplify. 2 with 2 is 1, over 5 is 1, over 5 is 4, therefore that will leave sine theta is equal root 15 over 4. And that is what they asked us to show. That is A. Part B, they are asking to find the two possible values of length, of the length of the third side, which is basically x. We already established that sine theta is equal root 15 over 4. I can use the first Pythagorean identity, sine squared theta plus cosine squared theta is equal 1. Substitute root 15 over 4 squared plus cosine squared theta is equal 1. It implies cosine theta or cosine squared theta is equal 1 minus 15 over 16, which is 1 over 16. I take square root of both sides. Don't forget to put the plus or minus in here. Therefore, cosine theta is equal plus or minus 1 over 4. Now we use the cosine rule. X squared, that is for B, is equal 4 squared plus 5 squared minus 2 times 4 times 5 times cosine the angle in between, which is theta. Now theta, cosine theta, one time we'll use it 1 over 4, and the other time we'll use it as minus 1 over 4. So that's it. X squared is equal 16 plus 25, that is 41, minus 2 times 4, 8 times 5, 40, times cosine theta 1 over 4. That'll be x squared is equal 31, or x is equal square root of 31. That is one value for the length of the third side. The other is x squared is equal 41 minus 40 times minus 1/4 cosine, and that's minus times minus is a plus. That'll be x squared is equal 51, or x is equal square root of 51 is of course centimeter the unit, centimeter the unit. Okay, next question. We're given a sector and they told us R is greater than 0, meaning positive, and the angle, central angle is 1 radian, and also we were told that the area of the sector is equal the perimeter. The length of the perimeter L is equal R theta, which is equal R times 1, and that should be R. That makes the perimeter area for a sector, area is equal half R squared theta, and theta in radian measure. In this case, it will be half R squared times 1, which is half R squared. So I get my area. My perimeter is adding this side and this side and this side. That will be R plus R plus R. So the perimeter is equal to 3R. Equate the two values. So half R squared, that's the area, is equal to 3R the perimeter. Move 3R to the other side. Or let's multiply by 2 first. That'll be R squared is equal to 6R. Move 6R to the other side. R squared minus 6R is equal to 0. Common factor R will be R minus 6 is equal to 0. Using the null factor law, R is equal to 0. Or R is equal to 6. And this is reject since R is positive, greater than 0. Therefore, the answer R is equal 6 units. They did not tell us what is. No, it's centimeters, so 6 centimeters. Okay, that is question 6, and that is